how frequently a application fails. He may know something from his experience, past experience, but if you are a new tester, a brand new person who has joined the team, you might not have the history. You might not have any idea what is the likelihood of failure. So in all the cases, it's a subjective analysis. So essentially, in a traditional RBT, what happens is we create a grid. So we take the likelihood of failure, impact of failure, either give it a degree of whether it's a minor impact or a visible impact or an interruption totally in the production environment. In terms of likelihood of failure, we say either it's a likely, unlikely, or a quite likely failure for that particular functionality. Or we take a 5x5 grid and basically take the impact of failure and likelihood of failure parameters and give them a range from very low to very high. Okay, and what you do is you basically do an analysis of every test case you have planned and you plot it in this grid. So you may for example hypothetically, let's say, have 100 test cases for a particular functionality. After analysis, you find that 10 of those 100 test cases, if they fail, they will create interruption in the production environment, but they're very unlikely to fail because it's a very stable component which has never failed. You may end up having 50 test cases which are in this middle portion of the grid. So it is quite likely to fail, and it will have a medium kind of an impact of failure if it fails in the production. So this analysis will give you the focus areas, the hotspots, where you need to focus while you do your testing. So you may probably try to do the high risk test first and maybe delay the execution of the lower risk or the medium risk test to the later part of the cycle. So the more high risk test you execute during the execution cycle, the more your earned confidence. So let's say everybody works to a deadline, right? So let's say you have a deadline of a software launch on a specific date. 1 week before that, you, in a traditional way of reporting, you probably would report that I have executed 80% of the tests. And business user, if they don't have the context, they might think, oh my God, who is going to execute this 20% of test in 1 week? But the earned confidence may be 95%. Because you have actually executed 95% of the high risk tests. Only 5% of tests are remaining, which are either medium risk or low risk. So that way of reporting gives a more contextual view to the business, to the senior management, who can take a conscious decision on whether to go ahead or not to go ahead. But this is the traditional way of risk-based analysis. The premise remains same, but what we are going to do here now is make this art science. So we will take the subjectivity away and we will bring objectivity in the analysis of impact of failure and likelihood of failure. How do we do it? Okay, before we go into the how, let's talk about analytics. So analytics is something which touches our everyday life, right? Analytics is everywhere. We use, let's say, e-com portals. They use analytics in a very heavyweight way to predict what is going to be the customer spend pattern. How are we spending? On which products are we spending? Even in our own companies, right? I mean, all of us are probably from the same industry. We work in somewhere or the other. In our companies, our company actually use analytics to determine whether the emails which are being received by the employees, whether they are spam or not. Many other kind of analytics are already in place in everything, every aspect of our life. Now what we are going to do is we are going to use the predictive analysis techniques, the business analytics into testing, into the risk assessment part of the testing to give deeper insight. That is exactly what Dex Black was mentioning in the morning, insight and confidence. So analytics is going to improve your insight, which again will improve your business outcome. Second important thing in this whole discussion is machine learning. So from this perspective, what we are saying is you have multiple data points when you have to take a decision, conscious decision in terms of risk, whether it's the impact or likelihood of failure. You have multiple sources of data to take that decision. It may come from the test management tool you are using, it may come from the production data reports, it may come from your defect management tools, it may come from anything. right? So you may have HPLM, you may have SharePoint for design documents, you may have Nagios, you may have Jira, you may have Bugzilla, you may have Rally, you may have many things. So what we are going to do is we will take all these data sources, all these data points, and we'll apply an algorithm which will basically keep on learning as it evolves to predict defects. Okay, so why analytics and machine learning is important? Why can't we do it manually? Even if we have access to the production data, we could have probably done it manually, right? Why do you need an algorithm? Why do you need a tool to do it? There are multiple things which you may not be able to do manually. Okay, let's take a simple example. We know about localized testing, right? So let's say you have a multilingual online portal which you are testing. So maybe you are testing the Spanish version of the portal, the French version of the portal, the German version of the portal, the English version of the portal. Now, as a tester, you might not know which kind of linguistic visitors would be visiting that online portal most. Right? Manually, by scanning the data or referring to some data sources, it will be very difficult for you to appreciate that kind of information. Secondly, let's say correlation between different data points. So, what is the correlation between the time you usually take for testing a requirement and the chances of it getting signed off? If you test more, is it getting signed off more often? Or if you test less, does it get signed off less often? Is there a correlation between these two data points? You need some kind of an algorithm to make that correlation. Again, another subjective thing which we probably do, if you have a history, if you know the designers, the developers who are developing the software code for you, designing the software code for you, by looking at past history, you may decide, okay, Arup is designing this. Arup usually does very bad design, so I will get more defects. Or rather, Nandini is doing this design. She is a good designer. I will get less defects here. Okay, but instead of creating that subjective perception, is there possibility of using analytics to improve the likelihood of failure of tests based on the designer profile? This is where a tool helps you. So what are the data points which impact the impact of failure parameter, and what are the data points which impacts the likelihood of failure parameter? So let's look at the impact of failure as a parameter. As we were discussing, reviews and reputation. The person who is developing it, the person who is designing it. How often are we finding faults in the piece of work they're doing? Live order volumes. Okay, so if we are talking about, let's say, a certain product, let's say broadband. A company is launching broadband. So what is the kind of volume of order that company is looking at? So if it is in millions, if it fails, it will have a huge impact. But if it is in hundreds, it may not have that big an impact. So live order volumes is a source of data which influences your impact of failure parameter. Fault return cost. Okay, so if you have a production fault, what is going to be the cost of fixing that kind of a fault? If due to that fault a device is returned or a service is, there is a churn, a customer decides not to continue with that service, what is going to be the cost associated to it? Device browser and usage. Okay, what are the primary profile of and the primary ways of users interacting with your software delivery, either the product or the service or the portal, whatever you are launching. So this data points impact your impact of failure parameter when you do the risk analysis. What are the different sources of data which impact the likelihood of failure? Components involved. Okay, so let's say you have a component A and a component B. Component B is stable, component A is unstable. You have thousands of faults in component A, merely few in component B. So if for a particular business delivery, component A is delivering, then you have high chances of getting faults, right, when you test. If component B is doing, you have less chances. Early test defects. So are there any early static testing kind of a testing or shift left approach being adopted, so that the defects would be more found during the design stage itself? If such thing or such techniques are being adopted, then the chances of getting faults in specific type of faults, design related faults, requirement related faults, will be less. Otherwise it will be more. Time scales. Is the length of the test window sufficient or it is too low? So if the test window is of sufficient length, you may have chances of getting the faults, you have better chances. If it is less, you have probably lower chances. Complexity of code. So probably you can use function points as a parameter to define whether it's complex or it's less complex. Whether, depending on the complexity, if it is more complex, you have more chances of failure. If it is less in complexity, maybe it has got a lesser chance of failure. So let's take a practical example to see how analytics and using these different data points from different sources actually help in removing the subjectivity and making it more a science than an art. So let's take an example where in the grid, after analyzing 6 different tests, we find, based on our perception, that all of them are quite likely to fail and the impact of failure would be moderate. So all would fall under the middle portion of the grid. So all has equal importance in terms of risk or equal level of risk. So if we now start using data points on this particular scenario, let's see how the risk profile changes. So let's say first we take the designer profile and make a correlation with the designer and the likelihood of failure. Let's say the scenario still doesn't change, it is still same. Now live order volumes. Depending on this 6 different type of tests, they are probably related to different products or different kind of orders in a production environment. So depending on the volume, your impact of failure changes. So which has got a higher volume will have a higher impact of failure, which has got a lower volume will have a lower impact of failure. The third parameter we apply is the trend of faults, production faults, according to specific products or services. So from past experience and data, we can figure out if, let's say, we have broadband, voice, data services, 3 different streams of products. So let's say broadband usually has more faults associated with it. Voice services has less faults associated with it for whatever reason. So that would basically change your risk profile again, because the likelihood of failure would change depending on the type of product you are testing. User device profiles. Okay, so we have multiple type of devices today. Let's say somebody is using Android, somebody is using Windows, somebody is using iPhone, iOS devices. Okay, now you know maybe Android is a much popular and it has got more penetration among users. So probably if your test is related to something which will cause a failure for the users who are using Android, that would have a more impact on the reputation of the company when it fails in production. So that would again have an impact on the parameter impact of failure. Lastly, components involved. So as we mentioned, depending on the type of software component involved in the delivery, whether in the past there has been multiple defects or it has got a lower defect profile in the history, it will again have an impact on the likelihood of failure. So as you can see, initially all of the test cases which had been scoped had got same risk profile, but after applying the analytics data and the algorithm against different parameters, the risk profile has completely changed. So it is giving you a better understanding of the risk associated with the software delivery.
So
Well, I mean 6 is just a hypothetical number. You can apply it on 1,000. All the tests are these 6 parameters? No. It can be more. It can be more. I've just taken it as an illustration or an example. It can be many more.
The reason I ask is that what are all the teams then you consider? Why is 6 or 7? What are all the teams?
I mean, we keep on adding. So if I use my own experience, so obviously, let's say here we have got 5. So maybe in a specific release, you get a specific nasty fault on something, okay? That basically will give you an experience, okay, this is a parameter which I was not considering before. So you keep on adding that. So the algorithm you will be building, you keep on enhancing it. Because the number of parameters you are considering, because manually or if you are doing it on the basis of perception, obviously it will be limited. But if you are doing it through a tool, if you are using an algorithm, you can keep on building on that algorithm. You can keep on adding more and more parameters as long as you have the data.
Just to add to it, just to add what you were saying, it should depend on domain to domain.
Correct.
If you are talking about internet domain,
absolutely.
These parameters.
Absolutely.
The banking domain.
Absolutely. Totally.
You need to look at the domain and see what are the parameters that will get into that.
Rajni, usually you're not very good with the red color. You don't bring in an emotional quotient into software testing. So why don't you use this as an area of improvement and do it in your project? Or, Saregama kind of a thing, a theme-based week. As a team this week, we're going to focus on the product from the white color. As a team, we're going to look at it from a yellow color. Bring in such fun concepts, because once you do that, you're able to better collaborate with your testers, but more importantly, it brings in the first C, which is better context into your project. So this is the first idea. Bring in thinking caps to promote better contextual understanding of what we're all doing. Idea number 2, let's embrace games in software testing. Isn't it fun? Go there, play games, and we continue to get our paychecks. So this idea was something that I've been fortunate enough to work with a person by name Ross Smith. He heads the engineering efforts for Skype at Microsoft, and he is, if you will, one of the pioneers when it comes to implementing workplace productivity through gaming. So he and we've had a lot of discussions, and this is an example coming from Microsoft on how they implemented games in Microsoft. And what is the problem we're trying to solve here? Again, although as testers we've started collaborating a lot with the developers, although we've been engaged much early on in the testing cycle, there is still boredom in what we do. We still feel that isolation once in a while. How do we break that and how do we better collaborate? Let's bring in games into software testing. To give you an additional premise here, gaming is just increasing in popularity, left, right, and center. If you take a global village of about 100 people, say if there are 60 of them who are Asians, 11 of them who are Europeans, 70 of them would be gamers. And if you take a cross section of kids, if say 52% of them know how to ride a bike, 20 know how to swim, 58% would know how to play a game. That is how popular in terms of statistics games is getting to be. And gamers have what it takes to succeed in software testing. Whether it's that result orientation, that aggressiveness, end user focus, all of these are characteristics that gamers show, and these are excellent characteristics for us to succeed in software testing too. So why don't we bring all of these into what we do on a daily basis? So what he says is, I'm not saying bring in games into all possible areas, handpick a few areas, especially localization testing, accessibility testing, usability testing, user-focused areas. Such areas try to build games. And today, we are much better off building games for software testing than where we were a few years back, because we have the right set of tools, frameworks such as the 611 Robert Dillon framework. It's a very useful framework if any of you are considering building games in software testing. It talks about emotions and outcomes, joy, anger, greed, and how they map to multiple outcomes, and based on which you can build very simple games. Don't go into building complex games. Simple ones, browser-based ones. For instance, how did they do at Microsoft? When Windows 7 localization testing was happening, Microsoft said, we have this localization vendor team, but in addition to that, we have this large, diverse international population at Microsoft. why don't we leverage our employees also to do localization testing? So what they did was they built this browser-based game, multiple screens of Windows 7 installables in different languages, built as browser-based sessions that employees could come in and play during lunch breaks or coffee breaks or whatever and report issues. And the results, he says, were phenomenal. Over 500,000 screens were evaluated through those browser-based games. Over 4,500 employees that participated in those games, with an average of about 120 screens per employee that were actually evaluated. So let's try to see how to build these small, simple games that can make testing more fun, more collaborative, and more productive as well. So this is idea number 2. Idea number 1 was for using thinking caps for better context. Second idea, let's embrace games for better collaboration. Let's move on to the third idea. Why don't we all innovate and practice mobile usability testing? We all know how skyrocketing mobile app development has gotten to be. From a sheer few thousands of applications that was there in 2007-8 time frame, we're about 1.7, 1.8 million applications as of the last few months. Global users are at play. So with all of these coming in, studies continue to show that if usability is not right, if the usability experience is poor, as many as 48% of the users would walk away from an application. If such is the power of usability, the question is, why don't we all do usability testing in our day-to-day testing jobs as well? I am not questioning the expertise of usability testers. They bring in a specific expertise which is completely valuable. But whether we are performance testers or security testers, localization testers, why don't we also start appreciating an application from a usability angle? Simple things. Let's just try to see if the end-to-end user flow is fine. If an end user using this application is going to be satisfied, what kind of error scenarios are reported? Are they graceful enough? Do they recover fair enough? Such simple scenarios, if you continue to take on, we will start appreciating usability and the customers also much better in our day-to-day operations. And again, in terms of best practices, here as well, we are in a much better situation today to do usability testing than when we were in the past. There are a lot of